Literal again. It's May 31st, 2017. Video number 4. I wanted to say a couple more things that I would have liked to include it in video 3, but it got a little bit too long. Talking about these balls that have lead pellets in the bottom of a plastic sphere about the size of a ping pong ball. There's air molecules above the lead, in between the lead too, obviously, and then there's a plastic shell. It serves as a gravitational unit, much as krypton, xenon, argon, all of these atoms that ride up in Earth's atmosphere, helium, neon, those are all noble gases, but those are not connected to any other gas molecules. They are each an individual gravitational unit. Now, a mass of lead would have lead atoms connected. Different elements have different allotropes, the way they structure, so that affects density. But when talking about a gravitational unit, earlier in video 3, I was talking about how many carbon atoms in the form of graphite would occupy the same space as a lead atom, in just a block of lead. Comparing volume to volume, that's what you're talking about when you're talking about density. And I made the case that the standard model doesn't account for the difference in density between lead and, say, carbon, or many more smaller atoms of elements when compared to lead, because the standard model only assigns such a scant amount of mass to electrons that you need a system that has many more particles orbiting. You can't just take the mass of the nuclei, the nucleus, as being the total mass, because when it comes to densities, you start dealing with volume and then mass per volume, and you actually run into trouble with the standard model, believe it or not. My system, everything that exists has mass, and all of the electrons, plus there's radio shells that are spherical, enveloping different layers of different types, enveloping atom nuclei, and this would account for the mass of those would be significant because there's so many of them, and this would account for the difference in mass between like lead and, say, carbon. If you added up, say, 20 carbon nuclei, the number of nucleons they would contain, say in carbon 12, and then you figured out exactly how many would fit in the same volume as one lead atom per their amount of material. It looks like a problem to me. My system solves that. But this, I want to mention gravitational units. These balls that I used in the water test that have lead in the bottom, air above the lead, and of course in between the lead pellets, and then encased in a plastic ball about the size of a ping pong ball. That's a gravitational unit right there. It, just like the chair, the wooden chair, all of its wooden parts connected, that's a gravitational unit. Diatomic gas molecules are each their own gravitational units. But anyway, I just wanted to mention that because right now a lot of the thinking is that the subatomic particles that we don't see, such as what is called dark matter. Now, dark energy, there's no reason to have that in my system, so I don't believe in that. But dark matter, it should be just subatomic particles. They're given all kinds of gravitational attraction uh, by people who are upholding the standard model of the atom as being perfectly accurate. And but all of those would be separate individual units as well. And without being connected, they can't collectively tug on anything more than just one of them tugs, because each one is movable. Oh well, we'll continue later on this kind of topic.